Okay. So I remember what we have said yesterday. We have a basis. We will discuss a little bit more this formula. We have a basis EI in our vector space. Then we introduce another basis, E prime. Now, with the rule of dummy indices, we can place here an index whatsoever, J, H, even I, okay? However, we want to remember, this is a point which for me was very difficult for many years to understand why you add the same symbol to the index, which the same label, this prime is a label, which you used for the new vector basis. In the calculations which we will do now, this requirement, it is not a requirement, this strategic notation will show how important is the concept of change of basis, and this strategic notation will allow us to understand the meaning of our formulas. I want to tell you that a Greek scientific philosopher, natural philosopher, said something which was translated in Latin, in nomine est natura rerum. In the name it is the nature of things. Our brain cannot work if you don't find for every concept the right name. Okay, so when looking for the right notation in mathematics, you are choosing the right names for the objects you are considering. So now, every index related to E prime will have the prime, and every index related to the starting basis will have no prime. Okay. Okay, now having said this, we change the basis. So I take a generic vector E prime J prime. This is a vector in the vector space. So you can write this as a linear combination of the vectors in the previous basis. Okay? What this means? That you can find Lij prime. These are real numbers, each one of them, and you have summation over I. So I write another time, but you have remarked that I'm becoming tired of writing these long formulas. I could write these the two formulas are totally equivalent. Okay. So what I want to say is that you have this index which is repeated, and this index is blocked. This formula is well written. Why? Because you have repeated indexes on one side, no repeated indexes in the other side, but free. This is what we will call free index. And the set of free indices is the same on both sides of the equation. And J prime can go from 1 to n. Maybe it is better if I use capital M for the components, for the dimension of our system, of our vector space. Okay, so this formula tells you how every new vector in the new basis is represented as a linear combination of the vectors of the old basis. This L is called the matrix of change of basis. Okay? Okay, now let us write EI equal LI J prime EJ prime. Okay. You can similarly write the old basis as a linear combination of the new one. Now, soon we will need to use these two formulas together. So it is very wise to avoid to call indices, repeated indices, in the same way. Okay. We have already said that dummy indices can change name. And when you are afraid that confusion may arise, it is better to change the name of the index, of the indices. Okay. Now, if you replace in this formula here, this formula, so replacing double star in star, what we get? We get E prime J prime equal Li J prime. And instead of this, we replace LH prime I E I. Sorry, H prime. Okay. And this must be an identity. By definition. Okay. So the right-hand side, Li J prime LH prime I, EH prime must be equal to E prime. Here you have a prime, of course. Here you have a prime. Okay. You know, this notation is helpful because it allows you to check if you are wrong. This is the new basis in terms of the old. You have the prime, you need to place the prime there. And as I'm repeating the prime also with the index, if one prime is skipping, you discover quickly its absence. Okay. So you get this equality. Okay. So what you have, that Li j prime L h prime I summation over the index, repeated indices I. This has to be, this is what? This is the coefficient in the linear combination of the new basis. Okay. So the component of the J prime vector in the new basis with respect to the new basis is clearly 1 if H prime is equal to J prime. And it is 0 if H prime is different from J prime. So what we have found, a trivial thing, if you like, that Lij prime LH prime I is equal to delta H prime J prime. So the matrix transforming EI into EJ prime is the inverse, because this is the definition of inverse matrix. It is the inverse of the matrix transforming E prime into EI, into E. Okay? So we have that passing from EI into E prime J prime, you have this matrix, this one. So Lij prime. Then passing from E prime H prime to EI, you have LH prime E, and the second matrix is the inverse, the first one. Okay. Okay, so we have established how transforming bases. Okay. Of course, both, I hope that you remember Cabelli Theorem. the one which tells you that given a matrix A and a vector X, AX equal B, admits a solution if and only if the rank of A is equal to the rank of AB, the completed matrix, which has as a consequence that this system has a unique, if A is n times n matrix, and X is an element of Rn, and B also. This system admits a unique solution, and this solution is given by X equal A minus 1B, if and only if the matrix A has determinant different from 0, or if you like, rank of A is equal to n. Why I'm reminding you this? Because a trivial consequence of this theorem, think about it, this easy, is that this matrix here, L, has determinant different from 0. So you can have the inverse. But in a sense, we have proven that it has an inverse because we have written this equation. And we know that there are different bases in our vector space. Okay, so here I am running a little bit, but you must learn how to fill the gaps in my presentation, finding the details. Okay, now we want to check what happens for components of a vector. So I write V, of course, when we change the basis. Okay. So I write V equal VI EI, a linear combination of the first basis, but it is also equal Vj prime E prime J prime. Okay. So I want to find the relationship between V prime and Vj prime. It is easy. What can I do? I will write V equal VI EI, and then I write EI as a function of the new basis. So I write VI, then I write L I J prime E J prime. So I have represented EI as a function of, remark how powerful is the up and down trick of notation. You know, you have EI down and you replace it with LI down, J prime saturated. So you have in every formula, you must check the conservation of indices. This is a standard trick for checking carefully what you are doing. Okay, so this is also equal to Vj prime E prime J prime. You have remarked that I am systematically forgetting to place E prime here. This is a bad habit which I was inherited by the books where I have studied this, because soon, and this makes the notation very confusing, in the books of linear algebra, this prime is not written anymore, so that a reader who is not careful may believe that the basis is the same. And this can be extremely confusing. Okay, so I try to keep this prime for a long time enough until you become accustomed with the notation. Okay, so at the end of the story, V is equal to Vi. You can use associativity of sum and product. So we can write in this way. Okay. I hope that this is not a problem for you. You know, okay, maybe it is worth that we spend some time on this. So this is a vector with the index I. Okay, and here you have a summation. So you have Vi. I write the summation. Okay. Maybe one time I want, the first time when I'm doing something new, I want to show you that this is not a diabolic trick. This is something which works. Okay. Summation over J prime of L J prime I E prime J prime. Okay. So this is the meaning of this compact formula. Now, summation over I from 1 to n, Vi can go inside the second summation. This is distributivity of product with respect to summation. So you can write in this way. And then you have Vi Li J prime E prime J prime. Okay. Then you can commute the summation, because you can change commutativity of summation, means that you can change the order of summation as you like. And then you get summation over J prime from 1 to n, summation over I from 1 to n of Vi L J prime I E prime J prime. Okay? Then you can take this out of the summation, because you have no, here you are making the sum over I. So there is no index of summation there. So at the end, you have summation over J prime from 1 to n of summation over I from 1 to n Vi Li J prime E prime J prime, which is exactly what I've written here. Okay. Okay. I hope that you have familiarity with this symbol. With some, if you have some doubts, think about this reasoning and consider how clever was Einstein in finding a notation which allows us to make these calculations so quickly. Okay, then I write this last representation and I find V J prime E prime J prime. So at the end of the story, maybe I want to copy this formula because I need it after. Okay. Then what we do, this you cannot do both. Okay. So what we have this equality. Okay. Now, just for having fun, I can write this like Vj prime E prime J prime minus Vi Lj prime Li E prime J prime equals 0. Then you can factorize on the right these vectors, and you find Vj prime minus Vi Li J prime E prime J prime equal 0. Okay? Now, the question is, what can we say about these coefficients? Remark, here on the left, you have, we can call this alpha J prime. We have a linear combination of the vectors E prime J prime, and this linear combination gives you 0. But E prime J prime forms a set, an independent set of vectors. Then for every J prime, alpha J prime is equal to 0. Okay, so in conclusion, we have Vj prime minus Vi Li J prime equal 0. Remark, this is an element of the vector space. This is a real number. Okay, so in conclusion, what we have, Vj prime is equal to Lij prime Vi. Now, let us copy the formulas of transformation. So let's go back. And I copy this formula of transformation. I clean up this. Okay. So if I have the matrix transforming the prime into the orders, the components in the old basis is transformed with the same matrix into the components of the vectors in the new basis. So this is the reason for which VIs are called contravariant. Components. Because they vary with the inverse matrix when you compare the transformation rules of the basis. Okay. So I repeat, you have the formula of transformation, which transforms the new, these are the new vectors of the new basis in the vectors of the old basis. So this matrix is the inverse matrix of the transformation matrix transforming the old into the new. We did all calculations for proving this. Okay? Now, when you want to transform the old components into the new components, you must use the inverse of the matrix transforming the old vectors into the new vectors. And for this reason, the components of a vector are called, in the basis, are called contravariant. These are the contravariant components. Now you can understand a basic part of our convention. The vectors in the basis have the indices low indices. So every basis has be careful, in the vector space VP, which we have at the beginning. So every basis in this vector space has indices, has low indices. Okay. The components contravariant components have an upper index. So rule in Levi-Civita notation. Covariant indices are written low. Contravariant indices are written up. So E prime J prime equal L I J prime EI. This index down is covariant. And we write it down. While VI, where it is, this formula which we have written here, VI, Vj prime is equal to Lj prime I Vi. Remark that this is the inverse of Lij prime. Okay. Upper indices are contravariant. So now in the convention of Einstein, when you write an index up, you know that it is varying with the inverse of the transformation matrix. The basic, this is the basic transformation matrix. This is the transformation matrix which transforms the basis vector into the old basis vectors into the new basis vector. And this transformation matrix is the one, this matrix rules every other transformation. Okay. So this is the covariant matrix. Every index down is changing with in a covariant way. You know, the co means in leading together. You know, one of the reasons for which I could accept to use English is that you will discover soon that the great majority of the words used in science in English are of a Latin root. You know, luckily Caesar did conquer Britain, and Britain was a part of the Roman Empire. And by the way, they didn't try to rebel against the Roman Empire. The Roman armies were obliged to abandon Britain in a certain moment, so they were not chased away. English is full of Latin words. So covariant means together variant. And contravariant means varying against or in the opposite way. Okay. So what happens now is that you have the basic rules of change of the components of a vector, knowing how the basis, the starting basis is changed. Okay, so we have VB, we have the basis EI, we have the components VI, EI, then we have E prime, J prime. The same vector represents like Vj prime, E prime, J prime. And then you have the formulas of transformation, which I resume here. So you have E prime, J prime equal Li, J prime, EI. And then you have that V J prime is equal to L J prime L J prime I VI. When you have any doubt, you think, what I'm writing, you know what I thought in the second where I was not talking. I said, what I'm doing, I'm changing upper indices. I must have upper index here, upper index there. I need a free index there, and the summation is over I. And I wrote the formula simply thinking about the rules, the basic rules. Okay, now I have VB star. You remember, but we will repeat what we said in the last lecture. We have linear applications in V star B. An element of V star B is sounding, which is linear. It is a mapping this is a real number, and this is equal to alpha L L V plus beta L W. So V star B is the set of linear functions defined in VB having values in R. Okay, so this is an element of R, this is an element of R. Okay, very well. Now, we have shown that LV equal to LVI EI is equal to VI LEI. And this formula suggested us to invent the dual basis to EI. So what we define, Li of a vector V is exactly the component vi of the vector in the basis from which we are starting. So we have blocked this and we change this. So now on, we are changing only the basis of VB. Okay. Once you have blocked the basis of VB, you have uniquely determined the components of every vector in that basis. These components are VI. By the way, these components are changing following this rule. Okay. And then you can define, what is this? A linear map from VB into R. Okay. So how many of these linear maps we have? Exactly n. So Li maps every vector V into its components in the basis EI. There is nothing strange in this, okay? So following the rule of Professor Franchetta, I repeated this 3 times, okay? So I'm trying to hammer this in your head. Using this definition, we can write L of V equal, using this one, LIV, LEI. Now, commutativity of product is granted. So we can write this LEI, LIV. Please remark that in order to have the conservation of upper indices in this formula, we labeled these linear maps, this linear map, with an upper index. Okay. Now, what is doing this formula? This formula tells us that L is equal to LEI LI. Please. You should not be confused by this last formula. When I write L equal LEI LI, I write an equality between functions. Here I have an element of V star B, and here I have an element of V star B. Okay. When I write this equation, what do I mean? That the image of the left-hand side of this equality for every vector V and the image of the right-hand side of this equality for every vector V is the same. Okay. And look here. This is exactly what we have written in the previous line. So we have proven that L is equal to LEI LI. Okay. So LEI is the component of L in the dual basis Li. Okay. Can you have the frozen image or you stay frozen while you are hearing my lecture? No, you stay frozen while hearing my lecture. Okay. Okay. Let us joke a little bit otherwise. Okay. So you understand this? You know, I have the effect of freezing the faces of the students. Okay. So now one could ask himself, I change, let's go back to our basic change. Changing formula. So I change the basis. You know, many years ago, I tried to teach this to my PhD students, and I got a kind of revolt. I think that you are too old if you are PhD student and you learn these things. Let us make a small break because, you know, these lectures are rather heavy and it is very good if we stop sometimes. Otherwise, I lose your attention. I have studied many years ago a book written by a famous neurologist from, I think, California Institute of Technology. He got several billions dollars for studying the human brain. And his results are rather interesting. The brain of human beings, when you are born, when one human being is born, are a chaotic set of connections between neurons. In the brain of a child, you see signals running all around. There is no clear pattern in the brain of a child. Then, when time is passing, at the end, the child learns a language. A part of his brain is frozen in a shape. By the way, they found that there is the brain part where you have the mother language and another part of the brain where you have a learned language, which is built in a different place. Bilingual children, those to which it was possible to teach two languages, have the same mother language center activated when they speak in one language or the other one. Okay. While, so I really don't know, it could be very interesting to discover if in my brain there is a location for Italian and a location for Neapolitan, and which of these two languages is my mother language, and which one, or if they are both my mother languages. Okay, there are some slight differences between these two languages. For sure, English and French are located in another place. Okay. What I want to tell you is that our brain, when you are more or less 25, 26, 27, is definitely blocked. and it is not reorganizing itself anymore. I'm teaching you what I studied when I was 19 years old. And believe me, I am not repeating these things before telling to you. So maybe I will risk I need to be very careful in order to avoid to say stupid things. This is an I here, by the way. Okay. The bad news is that some ideas, some theorems, some structures of mathematics must be learned when you are young enough. Otherwise, you will never master them. So I think it was a disaster to decide to teach this tensor algebra too late, because there is a refusal of the students to learn this. Okay, so I think that you are at the very last moment. How old are you?
I'm 23.
We are just on time. You have no more than 2 years before your brain is completely frozen. Okay, so try to understand these things before it is too late. Okay. So this is a motivation for having you, how to say, concentrated on this subject. Okay, so this is the formula of change of basis. Now I have Lj prime, I have Li. Remark that I am already, okay, I will write L prime, J prime, but you know, soon I will be so lazy that I will not write, there is no true reason, I will not write the prime. But be careful, this E is another E, because the index is different. So we are labeling, instead of writing this, we are lazy and we cancel this. You know, this was a mystery. If you go in the books of tensor calculus, they are not writing this explicitly. You must understand it. And it was very painful for me to understand this part, because, you know, I was confused. I said, okay, this is the same basis of that. What is going on? Okay. This formula is clearly meaningless if you don't have a change of basis in mind. So the vectors on the left-hand side of this equation are different from the vectors on the right-hand side of this formula. Now, you know, I should write L prime, J prime, because these are the dual basis of E prime. Okay. And Li are the dual basis of EI. Now, what should I write here? Okay, if you have learned by heart Levi-Civita rule, you will write immediately the formula, even if you are not understanding what you are doing. You write Lj prime I. Why? Why you write this? Let us teach you the tricks for the rule of conservation of indices, of the place conservation of indices. You have an Lj prime. By the way, why we wrote this prime at the top, this index at the top here? because we want to write this formula here. So LV is L of VI EI. VI goes out. You have LEI here. The index here is down. So LI must have the index up in order to keep the law of conservation of positions of the indices. So I have written this formula, and this formula we will need to prove. This formula tells you what? This formula tells you that Li are contravariant. Okay. So the basis of the dual space V star B is contravariant when you change EI into E prime J prime. Okay. Now, how can we verify this? Lj prime equal Lj prime I Li. How can I verify this? Lj prime V must be equal to Lj prime I Li V for every V. You agree with me? Two functions are the same if and only if their image for every vector, for every element of the domain, are equal. Okay, so this is, let me write in a better way. These two statements are equivalent. Okay, but look, what is this? This is Vj prime. What is this? This is Vi. We have proven this formula already. Okay. So in our scheme here, okay, you know, I should have, like in the lecture room, 2 tablets, because you know, usually in my lecture room I have 2 blackboards, one where I'm doing calculations and the other one where I write the results. Okay, so if I have E J prime equal L J prime I E I, L J prime is equal to L J prime I L I. This is the basis of V star B is contravariant. Okay. Okay. Now let us consider L. L of V, you know, this is, you can deduce everything in tensor calculus repeatedly applying this formula. You know, this is the crucial formula in tensor calculus. Okay. So what we have, I repeat the consequence of this formula. L is equal to LEI, LI, because this is LIV, LEI. Okay? So LEI is the component of L in the basis Li, which is determined by EI. Okay? Now you feel the need, you will see now quickly why, to write, to change the notation. Instead of calling this Li, it is much better if we call it EI at the top. So now on, we change the notation. You know, I was thinking when I decided to organize this lecture in this way, I was asking myself, should I call immediately LIE with the upper index or not? This is, in my opinion, misleading, because this vector here belongs to VB. This vector here belongs to V star B. Okay. However, the tradition in linear algebra talks about the dual basis of EI, and the dual basis is usually written in this way. So this formula now, with this change of notation, becomes LEI, EI at the top. Okay. So now you see the reason for which I need in this moment this change of notation. L, therefore, I can write with Li low, EI, you know, to write the formula Li, Li, where this is a covector. Sorry, I should not say yet covector. This is an element of V star B. And this is a real number. This is rather confusing. Okay, so I think that it is better now to make exactly in this moment, it is useful to change the notation. Okay, so now the problem is how Li are changing when we change EI into E prime J. Okay, Li, because of this formula, is equal to L applied to EI. So the formula of change is very easy. So what we do, we write Lj prime equal Lej prime. Then we represent Aj prime like Lij prime EI. This is the definition of the transformation formula from one basis to the other. And then, because of linearity, I have Lij prime Lei. This is linearity. So in conclusion, what I have Lj prime equal Lij prime Li. Okay? The components of L are covariant. With the change EI into E prime J. So, therefore, an element in V star B is called a covector. Okay, so let us resume everything in a single. I hope I managed to remain inside this table. So I have Ej prime equal Lj prime I EI. I know some colleagues who managed to pass the exam of rational mechanics in physics in Napoli, learning by heart this table without being able to explain the meaning of the symbols. I hope that I managed to explain you this carefully. Okay, then you have the component Vi is Vj prime is equal to Lj prime I Li. This is the rule of contravariance. Okay.
The last term should be Vi.
Yes, Ivan, thanks. I don't know why I'm sleeping. Okay. So you know that Ivan is looking after me since now. Okay. Now you have EI, the contravariant, the basis of V star This is the basis of covectors space, which is equal to L I J prime E J prime. Okay? But I don't think I want this. This is correct, but it is not what I want. Because otherwise, the nice symmetry which we are building is lost. So I must write E J prime equal L J prime I E I. You know, I wanted to show clearly the different rule of transformation of the co-basis. This is also the co-basis. Okay? Then what I have the last formula which we have proven. So we have that L J prime is equal to L J prime I L I. And this is the rule of covariance. So this is EI basis for phi B. Okay. So when you change the basis of VB, you cause a chain reaction. You change the basis. This is the basic change rule. Okay. Then, as a consequence, you get the rule of contravariance for vector components. Then you define the co-basis associated. This is the associated co-basis. And you understand that it is the associated co-basis. Why? Because the associated co-basis is taking a vector and is associating to this vector the components of this vector in the original basis. So clearly the associated co-basis is linked to the starting basis. Okay? And we have proven carefully that you have a basis of the covector space in this way. Then you write the change of variables for the covectors. So this is the rule of covariance for covectors components. Okay. So at the end of the story, we have learned how a change of variables inside a vector space is causing a systematic corresponding change of basis in the covector space, and all components of vectors and covectors change correspondingly. Okay, let us conclude with a remark. we never used the inner product. So what we are doing is independent of what we said is independent of the existence of an inner product. Okay? I give you some hints. Maybe you must think about these things. Consider a surface. Consider the tangent plane of the surface. Okay? The normal to the surface can be regarded as a covector. And force is a covector. If you think about these things, you also think about this. And you will find a reason for introducing inner products in our reasonings. Okay, so I think that we must end at 10 o'clock, right? So I think it is enough for today. Let me switch off the video recording.